Okay, we're continuing our notes from section 2.4 on the chain rule, but now what we're going to have to do is combine the chain rule with product or quotient rules. Remember, the product and the quotient rules are the way that you take derivatives of products or quotients. So if I look at number 5, I can see that I am taking the derivative of a product. So if I think of the first part as u and the second part as v, I can remember the product rule says I take u times the derivative of v plus v times the derivative of u. The key is, in the product rule, when I am taking the derivative of something, if that something is a composite function, I will have to apply the chain rule. All right, so let's give it a try. Y prime will equal. U means I keep the first part the same, 7x minus 4 to the third, times dv means I take the derivative of the second part. But the second part is a composition of functions, so the derivative of sine 2x is cosine 2x times 2. That's the chain rule that I just applied. I times it by 2 because that's the derivative of the 2x. Okay, plus the second half of the product rule. I take the second thing, sine 2x, and I multiply it by the derivative of the first one. But the derivative of 7x minus 4 to the third also involves chain rule. It would be 3 times 7x minus 4 to the second, but then I have to times it by 7. Why 7? Because that's the derivative of the inside function. All right, that's your calculus step. If you got that, you've got the calculus down. But now we have to do some algebra. So if I clean this up a little bit, this first term looks like 2 cosine 2x, 7x minus 4 to the third, plus the next one looks like 21 sine 2x, 7x minus 4 to the second. That's a pretty good answer. But I could also factor out the greatest common factor, which is a 7x minus 4 to the second power. That leaves me with a 2 cosine 2x times 7x minus 4 plus a 21 sine 2x. Either of those answers are acceptable. All right, let's try another one. Turn the page. Okay, this one will take a little bit of work, so don't write too big. All right, so this time we have a quotient rule. So just reminding myself, quotient rule is v du minus u dv over v squared. But again, each time I'm taking the derivative of something, I may have to apply the chain rule. All right, let's give it a go. Y prime equals the denominator 4x plus 7 squared times the derivative of the numerator, which would be 3 times 5x minus 4 squared times 5, minus the numerator, 5x minus 4 to the third, times the derivative of the denominator, which would be 2 times 4x plus 7 to the first times 4, all over the denominator squared. All right, if you understood that, you've got the calculus step down. The rest of it is algebra. All right, let's see if we can simplify this. So this first term that I have here, I could rewrite it as 15 times 4x plus 7 squared times 5x minus 4 squared, minus. Second term I could write as 8 times 4x plus 7 to the first times 5x minus 4 to the third, all over. And for the bottom, when you raise a power to a power, you multiply, so it's to the fourth power. Okay, now I can factor a greatest common factor out of the top. Between the first term and second term in the top, the greatest common factor would be 4x plus 7 to the first times 5x minus 4 to the second. If I factor that out of the first term, I'm left with a 15 times a 4x plus 7, minus, in the second term, I'm left with an 8 times a 5x minus 4. And the whole thing is still over 4x plus 7 to the fourth. All right, we're almost done now. So the next thing I notice now is the 4x plus 7 on the top can reduce with the 4x plus 7 to the fourth on the bottom. So on the top I now have a 5x minus 4 squared times something in the brackets, then I'll work that out in just a second. And the bottom is a 4x plus 7 to the third. Okay, so what is in those brackets at the top? Okay, let's go back and look. If I look there, both of those are raised only to the first power, both of the quantities, so I can actually distribute that. If I distribute the first part, I get 60x plus 7 times 15 is 105, minus 8 times 5x is 40x, negative times negative is positive 32. If I combine like terms, it looks like that whole thing will simplify to 20x plus 137. There we go. That would be the final simplified form. Again, all of that was algebra. All right, let's do another product rule. Okay, so here's a product rule. I have to notice it's a product rule because it's x squared times the square root of 1 minus x squared. You might think of that as x squared times 1 minus x squared to the 1/2. Okay, just a quick review of product rule, u dv plus v du. All right, let's do it. If you think you want to try it on your own, pause the video, try it on your own, and then take a look at the answer. All right, here we go. F prime equals, first thing, times the derivative of the second. For the derivative of the second, I have to be applying the chain rule because this is a composition of functions. So take a look at that. I did 1/2, 1 minus x squared to the negative 1/2, but then the derivative of the inside, which is negative 2x. Okay, plus the second thing, 1 minus x squared to the 1/2, times the derivative of the first, which is just 2x. All right, that's your calculus step. The rest of this is just, you got it, algebra. Okay, the first term, I can simplify this. The 2 cancels with the negative 2, so it looks like I get a negative x cubed times 1 minus x squared to the negative 1/2. And then plus 2x times 1 minus x squared to the 1/2. Now I want to factor the greatest common factor out. The greatest common factor between these two things, clearly there's an x in common, but there's also a 1 minus x squared to some power in common. Now when you factor out the greatest common factor, you actually take out the lowest of the two powers. So I'm going to take out a negative 1/2. Okay, in the first term, that leaves me with a negative x squared, plus in the second one, it leaves me with a 2 times 1 minus x squared to the first. You may have to think about that a little bit as to why that's 1 minus x squared to the first, but you can check pretty easily. If you distribute that, you'll be back to the 1 minus x squared to the 1/2. Give that a little thought and you'll get it. Okay, finally, I'm going to simplify what's inside that bracket. So I have x times 1 minus x squared to the negative 1/2 times, okay, let me clean up that negative 1/2. That's a little bit messy. Let me just clean that up. Negative 1/2. Okay, if I simplify this, I've got a negative x squared plus a 2 minus a 2x squared. So if I simplify, I think I get negative 3x squared plus 2. Hopefully I haven't made any silly arithmetic mistakes here. All right, that is chain rule along with product rule. All right, one more problem to make sure we've got it. Let's not forget some applications. Let's find an equation of a tangent line. Remember, to find an equation of a tangent line, you always need a point, and you always need a slope. And once you've got that, you can write y minus y1 equals m times x minus x1. So I usually put that over there as a way of reminding myself what it is I'm going to need to do. Okay, we're given part of the point. We're given that x is pi over 6, but we're not given the whole point. So we're going to have to take a minute and find y. Well, f of x is the secant of 2x. So that means f of pi over 6 is the secant of 2 times pi over 6. All right, well, 2 times pi over 6, we want the secant then of pi over 3. All right, well, secant is the reciprocal of cosine. So now I have to think, what's my unit circle value for the cosine of pi over 3? Well, the cosine of pi over 3 is 1/2. So 1 over 1/2 is 2. So my point is pi over 6, 2. Now to find my slope, I'm going to have to do the derivative and then evaluate it at pi over 6. All right, so again, if f of x is secant 2x, then f prime of x is, all right, you're supposed to remember your formulas now. The derivative of secant u would be secant u tangent u, but then times du. That's the chain rule, the times 2 part. All right, so I knew my formula for secant u. The derivative is secant u tangent u, but I have to multiply by du because there's a composite function. All right, now I'll evaluate f prime of pi over 6. Okay, I already know 2 times pi over 6 is pi over 3. So this is the secant of pi over 3 times the tangent of pi over 3 times 2. Okay, the secant of pi over 3 I already figured out. That's 2. The tangent of pi over 3, if you know your unit circle, is the square root of 3. And we have that too. So it looks like I'm getting 4 square root of 3. That's the slope. All right, now I'm ready to write the equation of my line. Y minus 2 equals 4 root 3 times x minus pi over 6, and we're done. All right, that was section 2.4. You should now go on and try problems out of the book on that section to make sure you've got chain rule down.